we talked about the integral without the limiting, without the endpoint. This is called the general antiderivative. This is called the indefinite integral. So without the endpoint, without the endpoint, this guy is gonna be a family of functions. It's gonna be a function with a plus c constant. However, when you have an integral with an endpoint, which is what we do today, when your integral goes from a to b, this is called a definite integral, and it's gonna be a number. So this is in case you get confused, this is the difference between the two. When there's no number involved, it's a function. When there's a number involved, it's a number. This definite integral has a few rather nice properties. If you find the area under a graph from A to A, then it's the same number, so it's not, and there's no area there, so you're going to get a 0. So that makes sense. When you find the area under a graph from A to B, it's going to be the negative of the area, well, the sine area from B to A. And this is because when you compute them, this is going to be the big F of B minus big F of A. It's going to be big F of A minus big F of B. So they are the negations of each other. The integral from A to B plus the integral from B to C is going to equal the integral from A to C. This is rather straightforward if you think of it in terms of the area. Because area is additive, if you compute the area from A to B and compute the area from B to C and add them up, you will get the area from A to C. So that makes a lot of sense. And so that's the third one. And for the last one, if my f function and my g function are continuous on an interval, then the sine area between the graph of f of x, which is the sine area of f of x minus g of x, is going to be the same as the integral of f minus the integral of g. So this is similar to the difference rule. The integral of f minus g is the same as the integral of f minus the integral of g, and this is true even when you actually have the limiting value here. In terms of the geometric sense, you can think of it this way. If I have two functions, which is my function f and my function g, so the integral of f minus g is going to correspond to that little thing there. So that's my first integral. This is the integral of f minus g. This is going to be the same as the integral of f . Right. Okay. So the area between f and g, it makes sense that it's just the area of under f minus the area under g. So when you make this subtraction, it makes sense geometrically that this difference is the same as this area there. So that's why this equation comes along. So let's actually take a look at this example here. I like to find the area. Okay, so there's a catch here. This one is the sine area, but the question is asking for the area. So once again, the sine area can be negative, but the area has to be positive. So let me see how to deal with this one. I like to find the area between the graph of x squared minus 2 and x. Okay. So that's a few things that I'm gonna have to think about. So I need to find the area. So it's gonna have to do with integral. But the question doesn't tell me what is the endpoint. So I don't know whether my integral goes from where to where. And I also don't know whether it's gonna be f minus g. What the hell? How do I do? I don't know if it's going to be f minus g, or I don't know if it's going to be g minus x. So it seems like that's too much confusion going on. It seems like I should actually just look at the graph of this guy first. So maybe that graph will tell me what is the endpoint and what function do minus what function. So let's actually see what the graph of this guy looks like. Fx, gx equal to x. This is pretty easy to draw. It's just a straight line. So that's my function g. My function f is a parabola. X squared minus 2 should look something like this. So the area between these two graphs that I'm looking for should be just the area here. So this is the only area between the two graphs. So to find the area between the two functions, it seems like what I'm going to have to do is to find what these two guys are, and they will be the endpoint of my integral. But what are these endpoints anyway? These endpoints, this is going to be when my function f meets the function g. So it's going to be the value of my f equal the value of my g. So then to find these two guys, I just need to solve for when f of x equals g of x. And that's going to be x squared minus 2 equal to x, or x squared minus x minus 2 equal to 0. I factor this guy, I get x minus 2, x plus 1 equal to 0. So the 2 points here are going to be when x equal to negative 1 and when x equal to 2. So that means I solve my first little dilemma. My integral is going to go from negative 1 to 2. Now I want the area, and it seems that if my function g is lying above my function f, so it would make more sense if I compute the integral of this guy with my function g minus my function f over the interval. So this is basically the integral that I'm looking for in order to find the area, to find the answer for this question. Show up, okay. So let me go ahead and do this integral. Let's see. So it's going to be the integral of negative 1 to 2 of x minus x squared plus 2 dx. So it's going to be x squared over 2 minus x cubed over 3 plus 2, and it goes from negative 1 to 2. So the number is not very nice, but, well, it's not too bad either. So if I plug in x equal to 2, I'm running out of room. Let me just write over here. If I plug in x equal to 2, I'm going to get 2 square over 2 minus 2 cube over 3 plus 2 minus negative 1 square, which is 1 square over 2 minus negative 1 cube over 3 plus 2. So I plug in x equal to 2, I plug in x equal to negative 1, and that's what I get. Let me try to simplify that. That gives me, let me see, 2 minus 1/3 plus, wait a minute, something doesn't look right. This should be 2x. So this should be 2 times 2, and this should be 2 times negative 1. Okay. In case you didn't catch me, I made a little mistake earlier. It's not, so it's actually not too bad, so I can break it in half. This 2, when I integrate 2, it became 2x. So this should be 2 times 2, and this should be 2 times negative 1. Okay. So I get 2 negative 1/3 plus 4 minus, let me see, this is going to be 1/2 plus 1/3, let me see, minus 2. So it's going to be 2 minus 1/3 plus 4 minus 1/2 minus 1/3 plus 2. Wait, something looks funny here. Okay. So I combine the integer term, I get 8 minus, wait, this is not 8, this should be 3. It should be 8 minus 1/3 minus 1/3 minus 1/2. So it's going to be this combined to be 3, so it's going to be, let me see, 8 minus 3, that's 5, 5 minus 1/2, so that's going to be 4 and 1/2. So that's going to be my area between the two function things. So when the question asks you to find the area of the two functions, this is going to be when you have to be a little careful, because you need, even especially for this example when they don't actually have the endpoint for you. So that means you have to find the endpoint, which is when the function values are equal. Because that's going to be when the functions are intersect. Not intersect, I mean intersect. That's going to be when functions are intersect. So then you know the endpoint of your integral. In this case, I knew that my function g lies above the function f, so I can compute the g minus f. In reality, you can also do f minus g, but you will see that your final answer becomes negative, so you take the absolute value. And that's going to give you a positive number, so that corresponds to the area.